Okay, so this is going to be the conclusion in our video series about this distance class case study. End of our software engineering series for now. So, in this episode I just want to tie up a couple of loose ends. Alright, so notice, number one, in our code, nowhere are we actually editing the value of meters. Whenever we call our operator plus, remember, because it's static, it's not bound to an instance. So, look, we're constructing a new distance based on our old distances. We're not actually modifying these values. We never modify these values anywhere. So, in C#, we can mark this with read-only. And what read-only tells us is this is assigned to only in the constructor. It's assigned to exactly once, and that is in the constructor. That's not entirely true. You could assign to it twice. You could do that, but this means you can only assign to it in the constructor, and that's it. Then it's constant from that point on. In C++, you just call it another const variable. In C#, you just call it a final variable. But C# gives it its own new keyword for it. Notice this is only used in classes, so we can't make a read-only int x equals 5. And that makes sense because we can already do const. That would be kind of redundant. So read-only is a really handy tool inside of your classes when you want things to only be touched in the constructor. This is particularly useful for dependency injection. I recommend looking that up, and in fact looking up solid design principles if you really want to get more into, good software design and software engineering. But that's not why we're here today. The second thing we're here for is, for those of you who are performance inclined, or rather I should say, if you care more about speed than space, there's another fun thing that we could maybe do here. Since this meters is read-only, we could also make a miles. Now you might say, well that's kind of redundant. We could set this. We could actually make this a nullable decimal miles, but we'll get back to that in a second. So we can make a decimal miles here. And inside of our as miles, notice we're multiplying meters by meters in a mile. Now remember that example case study that I was telling you about before? What if somebody was using our distance class exclusively for miles and only miles? It seems kind of silly to make, to convert it to meters and then make them convert to miles every single time. So what we could do, we need a way to say, is miles not yet initialized? So that's what we're going to do here. We're going to make this a nullable type, which simply means, in case you didn't see the other video, this is just a struct that has a decimal or a null value. Kind of like the big I integer type in Java, except it still follows value semantics. So we're going to say null for uninitialized. So we'll say if miles equals null, we're going to say that our miles equals meters times meters in a mile, and then we're going to return miles. Now notice what's quite nice about this. What is this? Cast to decimal. Sure, why not? This is really an unnecessary complaint. It's saying, well, what if miles is null? And miles will never be null, because if we're calling as miles, look, we check if it's null, and if it's null, we assign it, and then we return it. But as is the nature with these nullable types, you have to, turn them into a non-nullable type when we have to cast it to a non-nullable type when we return it. So this is really, not that necessary, but either the C# compiler or ReSharper was yelling at me for not doing it, so that's why that's happening. But notice in here, if our miles is not yet initialized, that is to say, if this is our first time ever requesting as miles, we'll calculate miles. Now remember, meters never changes because it's read-only. Meters in a mile never changes because it's a constant. So notice, this miles gets set exactly once. right here. And then we return miles. So that way, if we have a client who uses miles and only miles, and they use it a lot, we don't have to do a conversion every single time. We can just return our miles that we cached in here. Now notice that takes up more space, and that space will be there no matter what. So there will be space for miles. It doesn't matter if you use it or not. It's just that you only have to evaluate miles one time, and it's lazily evaluated, so it's only evaluated the one time that you need it, and then you just use the same value you had before. So this is another thing you might want to consider if speed is more important than space, because remember, every time we call this constructor, we have to make not only a decimal for meters now, we have to create a decimal for miles as well. And some of you who, well, if you know about value types, you're probably not watching this video. But another thing that we may cover at some point are value types, which are that's what structs are in C#. They're a value type. But when I say value type semantics, I mean that whenever you call assignment on them, it creates a deep copy and doesn't just copy a reference. If you wanted to do something like that with distance, and this is nice because it keeps things a little smaller and it could be more performant, but there are trade-offs. And usually the answer is it's not worth it. But if you did want to do something like this, like that, adding a whole nother field for miles and every other type you would inevitably add, that would be very, very expensive. So these are just more, decisions that you might want to make if you're making a class like this. Now this is a nice, easy example because everybody knows what distance is, but so this is more of an academic case. But these sorts of principles can still be useful to you if you're designing, a domain-specific class. But for now, this is going to conclude our first video series on software engineering in C#. I hope you found it useful.